Hello, everyone. So today we is webinar number 6, and we're going to talk about differentiation. So differentiation is an incredibly powerful tool, especially when you're doing physics, because if you differentiate the distance traveled, you get velocity, and if you differentiate velocity, you get acceleration. Differentiate a derivative is the rate at which something is changing. And the two pillars of calculus. So basically, calculus is mostly about differentiation and integration. And this cartoon is a very realistic way of viewing differentiation and integration. So differentiation, you literally have 4 rules. Well, actually, I'd say 3 rules rather than 4. It's the chain rule, the quotient rule, and the product rule. The power rule is just, well, it's just a standard derivative. Well, we're going to do all of them. And that's all. If you know these 3 rules, you know how to differentiate. And at the end, we will attempt a really complicated function. We will try to find the derivative of this function, of this humongous function. But yeah, no matter how difficult the function is, if you know the rules of differentiation, you should be able to do it. So literally after this session, you should be able to differentiate any function whatsoever. Okay, integration is way more complicated. You can study integration for years and years and years, and you still won't know everything the world knows about integration. So, yeah. So I just can say I thought I saw a book called Integrals of Known Functions, and it contained like something 500 pages or something. So it's it's absolutely massive topic. Anyways, what is a derivative? Well, if you have a function f of x. Let's say f of x is a function, y equals f of x, and if you draw the graph of that function, it looks something like this. And at any point, this function has a gradient. If you draw a tangent line at any point, so what I'm trying to say, that the derivative is the gradient of f of x at a point. If this is x, so the gradient of the function here is approximately 0.5. Probably the gradient is about 0.7. This is the gradient is 1, gradient is 0.7, gradient is 0.1, gradient is minus 0.2, minus 1. Okay, so you can see that it's the steepness. Yes, it's how steep the graph is. The steeper the graph is, the bigger the derivative. This is a simple way to try to understand. If you take a function, so let's say we have a function f of x, this is x, this is y. This is f of x. Let's choose another point. Let's say we choose this point, and this point is x plus delta x, where delta x is a small change. small change. And if I draw this, this is of course f of x plus delta x. So it's the value of the function at point x plus delta x. And now we know what the gradient is. So if this is point A and this is point B, the gradient of AB, we draw a straight line from A to B, is the change in y divided by change in x. So the gradient of AB is change in y divided by change in x. But change in y is the difference between these two values. So it's f of x plus delta x minus f of x. And the change in x, well, you can see is x plus delta x minus x, x plus delta x minus x, which is just simply delta x. So f of x plus delta x minus f of x divided by delta x. Now, if we move point B closer to point A, move point B closer to point A, effectively make delta x smaller. So make delta x smaller, so move point B. So let's say point B moves here to position B dash. We get a bit different triangle. Then we move it further, B double dash, and it gets smaller and smaller and smaller. And when the delta x, is my voice clear to people? Um, can you hear me well? Somebody said that they can't hear me well. Assuming that means yes. Yeah, I think if you oh, there was a little crackling earlier. If you find that there is crackling, so you can try switching, going out and back in. Move point B closer to point A, make delta x smaller, and the line AB, the gradient of AB becomes the gradient of the curve at point A. So gradient AB gets closer to the gradient of the curve at point A. And that's what a derivative is. So the definition of a derivative, the derivative f dash x is by definition the limit when delta x tends to 0 of f of x plus delta x minus f of x divided by delta x. That might look scary, but let's look at an example and try to sort it out. So f of x is x squared. F of x is x squared. We need f of delta x, f of x plus delta x. So we just substitute x plus delta x squared. Right, on a graph, it would look like this. This is the problem. derivative f dash of x is the limit when delta x tends to 0, and we substitute f of x plus delta x, so x plus delta x squared. Sorry, what I meant is, if this is x, then this is x squared, of course. And this is x plus delta x, well, this is, of course, x plus delta x squared. People say it's crackling again. I can try switching on and off. Try to come back. X squared and x plus delta x squared minus x squared divided by delta x. So that's equal to the limit of delta x tends to 0. And if I open the brackets, it becomes x squared plus 2x delta x plus delta x squared minus x squared. And you can see that x squared cancels. We get delta x. If we divide both by delta x, we get the limit, delta x tends to 0, of 2x plus delta x. I've divided by both by delta x, right? So I get this. But delta x tends to 0, so this is just 0, so it's equal to 2x. So the derivative of x squared is 2x. So if f of x is x squared, then f dash of x is 2x. And as a general rule, this could be written simply as x squared dash is 2x. Generally, x to the power n dash, x to the any power, is equal to n multiplied by x to the power n minus 1. Surely x plus delta x is x x plus delta x. Okay, so what are you trying to say? That this thing tends to 0 and this thing tends to 0? Well, true, yes. But you would get something that tends to 0. You wouldn't get 0. You would get something that tends to 0. But this is called an indeterminate and undeterminate of 0 divided by 0. 0 divided by 0 is a problem in math because it can be anything. Look, let's say we have a limit of x tends to 0 of x squared divided by x. Well, this is 0 and this is 0, so it's 0 divided by 0. But if we divide by both sides by x, it becomes limit x tends to 0 of x over 1. And now you can see it's 0 over 1, so it's actually 0. And if you do limit x tends to 0 of x divided by x, now x, they both tend to 0, so it's again 0 divided by 0, but it's actually 1 because you can you can simplify by x, you get 1. And limit of x tends to 0 of x divided by x squared is the same as the limit of x tends to 0 of 1 over x. And that's infinity because 1 divided by 0, well, it's infinity. It's not equal to infinity, it tends to infinity. That's a slight difference. I don't think I'm ready to talk about limits thoroughly, like as I should talk about limits. Here I'm just introducing the intuitive idea of limits, if you may, and intuitively you understand that yes, this tends to 0, this tends to 0, but if you divide both sides, top and bottom, by delta x, it becomes 2x. Well, you can take delta x out, 2x plus delta x divided by delta x. Delta x cancels, and you get 2x plus delta x. Now, 2x is not 0, but delta x tends to 0. Therefore, that tends to 2x. I hope that makes sense. Well, the numerator is not equal to 0. It tends to 0. And these are not the same thing. Like, mm, 1 over x, where x tends to infinity, when this tends to 0 when x is infinity. Can you say that this thing is exactly 0? Well, no, it can't, because 1 over x is never actually 0. But it tends to 0. It becomes really, really, really close to 0, which is not the same as 0. I, I don't know if that makes sense to you. If you open Desmos and you just draw 1 over x, and you can see that the function gets really, really, really small, but never 0. Look, it's 0.02. Let's move further. It's 0.0058. It never actually becomes 0. So the same way, this top, the numerator, becomes really, really, really small, but never becomes 0. And this delta x becomes really, really, really small, but never actually becomes 0. And the beautiful thing is that you can simplify the expression and get an expression that is not 0, even though. So basically, 0 divided by 0 can be anything. And in this case, 0 divided by 0 is 2x. I don't know if it's weird. It's weird. Like calculus is weird in that way, but hopefully it makes some sort of sense. Okay. Now, so generally speaking, the derivative of x to the power n, and this is the result that you really need to remember. Remember. Now, okay, I made a typo here. What I meant to say is 1 over x from the first principles. Okay, so here I've got a function which is 1 over x. F of x equals 1 over x. And let's say that this is x, and this is x plus delta x. So this would be 1 over x, of course, and this would be 1 over x plus delta x. So the derivative of x is the limit of delta x tends to 0 of 1 over x plus delta x is minus 1 over x over delta x. Okay, so it's the limit of delta x tends to 0 Now I multiply this by x. Let me choose a different color. I multiply this by x. I multiply this by x plus delta x. I find the common denominator. And I get x over x plus delta x minus x plus delta x over x plus delta x all over delta x. I simplify this and I drop this down. So I add the numerators. So x minus delta x all over x plus delta x. The limit as delta x tends to 0. Now you can see that x minus x cancel. Let's use blue color. X minus x cancel. Now you get minus delta x divided by delta x, so delta x cancels, so you get minus 1. So now you have the limit as delta x tends to 0 of minus 1 divided by x, open bracket, x plus delta x. Okay. Well, as a matter of fact, you can open the brackets on the bottom and you get the limit of delta x tends to 0 of minus 1 over x squared plus x delta x. And now you can say that delta x tends to 0, so this thing tends to 0. And therefore, the limit of this expression is minus 1 divided by x squared. So what does that mean? That means that the derivative of 1 over x is minus 1 over x squared. How does that work? And how does that link to the previous? You remember previously we said that x to the power n is n multiplied by x to the power n minus 1. Let's try. So if x to the power minus 1, because 1 over x is x to the power minus 1. So x to the power minus 1 derivative is n, so minus 1, right? So this is the formula, minus 1 multiplied by x to the power minus 1 minus 1. So minus 1 x to the power minus 2, which is minus 1 over x squared. So the formula works. Okay. I hope that makes sense, right? Using standard derivatives. So the standard derivatives that we need today, standard results. First of all, well, we already know that x to the power n is n x to the power n minus 1. Example, x to the power 7 derivative is going to be 7 multiplied by x to the power 7 minus 1, which is 6. Okay, the first standard result. The second standard result is sine x. The derivative of sine x is cosine x. Easy. 3. The derivative of cosine x is minus sine x. Also quite easy. And 4. Any constant, the derivative of any constant is 0. Example, 3, derivative of 3 is 0. Cool. This is the first thing. Now, let's talk about linearity. Linearity. What is linearity? Linearity means that the derivative of a sum is a sum of derivatives. So the first property of linearity, if you have a constant multiplied by f of x, and you're trying to find the derivative, it's simply going to be k multiplied by the derivative of x. So if you have a constant times a function, it's the same as multiplying the constant by the derivative, right? And two, if you have f of x plus g of x, you have two functions, and you're trying to find the derivative of a sum, it's the sum of derivatives plus g dash of x. I think examples, we need examples. So for example, for the first example, if you have 4 multiplied by x cubed, the derivative, you can just find 4 multiplied by the derivative of x cubed. Oh, apologies. Yes, like this, which would be 4 times 3x squared, because we know the derivative of x cubed is 3x squared, which is 12x squared. For the second one, if you have x squared plus x cubed, for example, then you just find the derivative of x squared separately, and then the derivative of x cubed separately. The derivative of x squared is 2 multiplied by x to the power 1 plus 3 multiplied by x. So the first is the standard, and this is linearity. So derivative is linear. Well, think of it this way. If you have like 4 multiplied by f of x, this could be written as f of x plus f of x plus f of x plus f of x, right? And if you're trying to find the derivative, 4 times f of x, the derivative is f dash of x plus f dash of x plus f dash of x plus f dash of x, so which is simply 4f dash of x. So that's how it works. Now, what you are asking is why is 4 times f of x not 4 dash of x? Well, first of all, 4 dash is 0. 4 dash is 0, so then it doesn't make any sense. Secondly, if you have f of x multiplied by g of x, this is not linearity. Linearity does not work like that. It's not f dash of x work. So that's not true. So that's not true. It only works for sums, not for multiplication. For multiplication, if it's a constant, you can take it out. If it's not a constant, then we have to use the product rule, which we study down there. Well, actually, in the next problem. So for now, let's just do these. So question 1, x cubed plus 2x squared minus 5x plus 7. So you're allowed to do them separately. Just do each derivative separately, and it's going to be f dash of x is equal to 3x squared plus 4x minus 5. We leave 5, we keep the 5, and then x is going to be 1 multiplied by x to the power 0, which is just 1. And then 7, well, the derivative of 7 is 0. So 0. So it's 3x squared plus 4x minus 5. That's it. 2. Sine x plus cos x. Well, we know that the derivative of sine is cos x, and the derivative of cos is minus sine x. So very straightforward. 3. 4 times 5, x to the power 5. So f dash of x is 20 x to the power 4 minus 3 cosine x plus 0. That's it. That's 0. So standalone number is always 0. And if a number is in front of a function, we just keep the number and do with the function whatever we normally do with the function. So the next one, the derivative is 10. We keep the 10, and then we find the derivative of cos, and the cos is minus sine. So minus 10 sine x minus 6. So we keep the 6, and we multiply by 4x cubed. In other words, it's minus 10 sine x minus 24x cubed. 5 f dash of x is, so 6x, yep, plus 2 cos x plus 5 sine x. Number 6, f dash of x is 7x to the power 6 minus 12x squared plus 2 cos x. That's it, plus 0. Okay, now let's look at these questions. So these are slightly trickier, but we still use the same formula. We use the formula x to the power n, derivative is n multiplied by x to the power n minus 1. So question A. 2 multiplied by square root of x is 2x 1/2. And if we differentiate that, that's equal to 2 multiplied by 1/2 multiplied by x to the power 1/2 minus 1. Which is just 1 multiplied by x to the power minus 1/2, which is 1 over x to the power 1/2, which is 1 over root x. B. 3 divided by x squared, that's 3 multiplied by x minus 2. So if you differentiate that, it's going to be minus 6x to the power minus 3, which is minus 6x cubed. D. Oh, well, yes, D. Just going to skip C. To do D, you need to open the brackets first. So it's going to be 1/3 minus 2/3 x to the power 3. And now if you differentiate that, you find 4/3 x cubed minus 6/3, which is 2x to the power 2. Okay. Let's do question G. G, so 2x plus 3 over x. X plus 2x over x plus 3 over x, which is 2 plus 3x minus 1. And if you differentiate that, that's 0 minus 3x to the power minus 2, which is minus 3 over x squared. Okay. I is quite an interesting one. It's a very important one, I. So 2x cubed plus 3x divided by square root of x. That's 2x cubed plus 3x divided by x 1/2. So it's going to be 2x cubed divided by x 1/2 plus 3x divided by x 1/2, which is 2x to the power 5 over 2, because 3 minus a half is 5 over 2, plus 3x 1/2, because x to the power 1 divided by x 1/2 is x 1/2. And if you find the derivative of that, 5 over 2 plus 3x 1/2 is, well, 10 over 2. 10 over 2x to the power 3 over 2 plus 3 over 2 x to the power minus 1/2. So this can be simplified as 5x 3 over 2 plus 3 over 2 x to the power minus a half. And, well, you can write it down in a different way. You can write 5x root x plus 3 over 2 root x, but that's not necessary. You don't have to write it like this. Okay. I hope that makes sense. Now, for the other questions, you just need to open the brackets and then differentiate them as power functions, right? So that's the power rule. Remember, that's called the power rule, which we referred to at the beginning of the session. Okay, now we talk about the other three rules. First, we do the product rule. Product rule. Product rule is one of the easiest rules. Basically, if you have a function u multiplied by v, and you want to find the derivative, is going to be u dash multiplied by v plus u multiplied by v dash. That's the simplest way to write it. And an example would be, well, you have x cubed multiplied by cos x, let's say. And if you want to find the derivative, first you find the derivative of x cubed. You multiply it by cos x plus x cubed multiplied by the derivative of cos x. So it's pretty straightforward. So the derivative of x cubed is 3x squared multiplied by cos x plus x cubed multiplied by sine x minus sine x, so which can be written as like this. Just put the minus here. That's it. Example. Well, we don't have too many. Well, let's do these. Let's do number 7. 7. X squared sine x dash is x squared dash sine x plus x squared sine x dash, which is 2x sine x plus x squared cos x. That's the answer. 8 x cubed minus 1 multiplied by cos x. So you can use the product form. So x cubed minus 1 multiplied by cos x plus x cubed minus 1 multiplied by the derivative of cos x. And then the derivative of x cubed is 3x squared minus 0, because the derivative of 1 is 0. So 3x squared minus 0 multiplied by cos x plus x cubed minus 1 multiplied by minus sine x. We can simplify this. We can get 3x squared cos x minus x cubed minus 1 sine x. I don't think I need to open the brackets. Just leave it like this. Okay, do we have a poll? There's only 16 of you. I think I can open the chat. How do I open the chat? On a scale of 0 to 10, how well do you understand the product rule? 10 being a fully understand the product rule. Type in the chat, please. Do we have the chat? Chat is here. Yes. Okay, 9, 10. All right. Ooh, that's very good. That's very good. Great. Okay. Perfect. Okay. Now the next rule is the quotient rule. Quotient rule is very similar to the product rule, but instead for division. Quotient rule. The quotient rule says if you have u divided by v dash the derivative, the product rule is that the derivative of a product of two functions is the derivative of the first function times the second function plus the first function times the derivative of the second function. This is called the product rule. The quotient rule is for division. When you divide two functions, it's the derivative of the first function multiplied by v minus u times v dash divided by v squared. So this is known as the quotient rule. An example be, well, if you have x cubed divided by sine x, and you want to find the derivative of that. Well, you find the derivative of x cubed multiplied by sine x minus x cubed multiplied Hello. You should be able to hear me now. Okay. So tan x is actually sine x divided by cosine x. So if you want to find the derivative of tan x, you can find this using the quotient rule. So it's sine x dash times cosine x minus sine x multiplied by cosine x dash divided by cos squared x. And if you do this, the derivative of sine is cosine x multiplied by cosine x minus sine x multiplied by minus sine x divided by cos squared x, which is cos squared x plus sine squared x divided by cos squared x. And if you remember, cos squared x is plus sine squared x is 1. So 1 divided by cos squared x. And 1 divided by cos squared x is actually sec squared x. So the derivative of tan x is sec squared x. Okay, let's do two more, number 9 and 10. So they're quite straightforward. And 9. So sine x over x squared dash is going to be sine x dash times x squared minus sine x multiplied by x squared dash divided by x squared squared, which is cos x, x squared times cos x minus 2x sine x. Sec is 1 over cos x, yes. Second x is 1 divided by cosine x. I mean, this result is good. You don't have to simplify it further. So yes, 2x sine x divided by x to the power 4. That's it. Very nice. Very neat. 10 x cubed divided by cos x dash. Okay, a little bit boring. I'm going to modify it. I'm going to say 3 quarters. 3 quarters. So it's going to be x to the power 3 quarters dash multiplied by cosine x minus x to the power 3 quarters multiplied by cosine x dash divided by cosine squared x. And this is going to be 3 quarters, x to the power 3 quarters minus 1, so x minus 1 quarter, cosine x minus, well, cosine x is plus x to the power 3 quarters multiplied by sine x divided by cosine squared x. So we've studied two rules so far. If you recall from the first cartoon, we've done the product rule. We've done the quotient rule. Yes, we have done the power rule. Now it's the chain rule. The chain rule is probably the hardest rule to understand. But once you get it, there's no stopping you. To explain the biggest problem with the chain rule is that there's no good way of writing it down. Every way you write it down, there's only awkward ways of writing it down. I'm gonna write down a few different ways of the chain rule. Ooh, why does cos squared x plus sine squared x equals 1? That's a good one. Because of Pythagoras theorem. Well, if you have a triangle, y sine squared x plus cos squared x equals 1. Oh, if this angle is theta, this side is opposite, O. This is A, adjacent. Okay, let's call it just x, x, y, and z. Okay, sine x is x divided by z. Cos, so sine theta, sorry, cosine theta is adjacent divided by hypotenuse z. And if you do sine squared theta plus cos squared theta equals x squared over z squared plus y squared over z squared equals x squared plus y squared divided by z squared. But x squared, but from Pythagoras theorem, x squared plus y squared is z squared. So it's z squared over z squared equals 1. So sine squared theta plus cos squared theta is 1. This is the main trigonometric identity. Anyways, back to the chain rule. Chain rule. Okay, notation. There are different notations, and all of them, as I said, are awkward. The most user-friendly, I'll show you the most user-friendly notation. So chain rule is the derivative of a composite function. So if you have f of g of x, that's called a composite function. Composite function. And the derivative of g of x is, well, the derivative. Let's not make it harder for ourselves. The derivative is f dash with respect to g multiplied by g dash with respect to x. And this is the most user-friendly notation, and it looks horrible. You must agree with me. Another way of writing down, because the derivative can also be written as df dx. It can be written as df dg multiplied by dg df. This notation makes sense, although it doesn't really answer many questions. What actually, with respect to g? Well, with respect to g means you think of g as your variable, in short. But don't worry. Let's do some examples, because the only way to understand the chain rule is through an example, because these are really awkward. I want to write awkward, but I forgot how to spell awkward, so I'm not gonna. It's very awkward. Anyways, example. You know that x to the power 8 dash is 8 multiplied by x to the power 7. That's the standard result. That's the power rule. Power rule. That's easy. But what if instead of x you had something else? So for example, x cubed plus x squared to the power 8. and you wanted to find the derivative of that. Wouldn't it be just brilliant if it was 8 multiplied by whatever that is, 3 plus x squared to the power 7? Well, it almost is. What you need to do is you find the derivative as if it's just x to the power 8, and then you multiply it by the derivative of the inside function. So this is called the inside function, and this is the outside function, outside. So you find the derivative of the outside function and multiply it by the derivative of the inside function, and the derivative of x cubed plus x squared dash. So that's going to be 8 multiplied by x cubed plus x squared multiplied by 3x squared plus 2x. And that's it. Okay, another example. X squared plus sine x to the power 3 derivative. So what you do is you forget that this is something cubed. You just write it. Well, it's something cubed. It's like g cubed. So you find the derivative of, so it's like g cubed, right? So you just find the derivative. So it's 3 multiplied by g squared, which is 3 multiplied by x squared plus sine x squared. So you just find the derivative of that. And then you multiply by the derivative of the inside function, which is 2x plus cos x. That's it. So you need to think of what is the inside function, what is the outside function. Okay. A slightly more complicated example. Sine x to the power 4 plus 3x dash. So you want to find the derivative of this. So you find this is the outside function. Outside. This is the inside. So you find the derivative of the outside function. So it's going to be cosine x to the power 4 plus 3x. So you find the derivative as if it was, well, as if it was just simple sine x. And then you multiply by x to the power 4 plus 3, oh, sorry, 4x cubed plus 3. And that's it. That's how you use the chain rule. Okay, on a scale of 1 to 10, give me a number, please. Oh, okay. A range. Okay, we got different results. Well, sorry to pinpoint, like, would another few examples help? Or theory. So people who put low numbers. Do you think another example would be good? Or okay. Other examples. Yeah, is there any specific parts? But you understand how to differentiate like basic functions, right? You know how to differentiate sine x. The derivative of sine x is cosine x. The derivative of sine x cubed is cosine x cubed, but then multiplied by the derivative of x cubed. And it's actually, if you think about it, this is also true for the first one, or the other one, because you multiplied by the derivative of x, but the derivative of x is just 1. So it's just cosine x. So the derivative of sine, you can think of it this way. Oh, okay, so that's cosine x cubed multiplied by 3x squared. You can think of it this way. Sine of x, the derivative of sine x is cosine x. But the derivative of sine g, so is cosine g multiplied by g dash. So yeah, sine of x squared plus cosine x, for example, dash is cosine of x squared plus cosine x. So just as you would normally, multiplied by the derivative of that. So multiplied by x squared plus cos x dash, which is cos x squared plus cos x multiplied by 2x minus sine x. Does that make more sense? Was it row one and cell? I'm not sure any of this. I've never seen this before. That's okay. I mean, if you didn't follow from the start, that's perfectly okay. That um you can watch my other webinars on the same topic, but do read the assignment as well, which should help. Okay, you can watch the recordings of the previous one. Try finding where are the recorded webinars kept? A good question. So if you go to our website, you go about COMPOS webinars, and you go to all COMPOS webinars. All year 11 webinars is only for this year, so you need to all COMPOS webinars, and then you can click on year 11 last year, 2024 year 11, and if you click on that, you will find differentiation. So that's webinar 5 last year. So let's look at this example. So number 11. If you want to differentiate that, you just differentiate sine. The derivative of sine is cosine. Cosine of x squared. And then you multiply by the derivative of the inside function. So times 2x. And that's it. That's all you need to do. Number 12. The derivative of this function is the derivative of cosine. Yes, Khan Academy. Yes, absolutely. A very good resource. The derivative of cos. So it's just sine. Well, minus sine. Minus sine 3x to the power 4. Then you multiply it by the derivative of 3x to the power 4. So you multiply it by 12x cubed. And that's it. So let's just recap the rules that we've studied today. Recap. So we studied that the derivative of x to the power n is nx to the power n minus 1. We studied the derivative of a constant is 0. We studied that the derivative of the product of two functions is u dash v plus u v dash. The derivative of the quotient, quotient of u dash v minus u v dash divided by v squared. And the chain rule, which is the super awkward one, is that the derivative of a compound function is the derivative of f with respect to g multiplied by the derivative of g. So this is the outside function and this is the inside function. Don't try to fully understand this notation. It's just bad. If you find a very good way of writing down the chain rule, which is easy to understand for people who see it for the first time, I would be very grateful. But I have never seen a way of writing down the chain rule without people saying, "What on earth is this? Like, what?" Okay. So, yeah, hopefully that makes sense. Now, let's just have some fun. So I said you will be able to differentiate any function which is made up of the three basic ones that we have studied, because if you open the table of derivatives, and you will see that there's slightly more functions that you will encounter uh, in your studies. Well, why is it so awkward? Yes. These are the functions that you will encounter in your life. So you already know the first few. So you know this one, you know this one, and you know this one. The other ones, you just learn them. You can derive them, of course, but you learn them. You won't need these ones anytime soon. You won't need these ones anytime soon. Yeah, but anyways, there's a table of standard functions, and you find the derivative. So once you know the table of the standard functions, and you know the three rules of differentiation, the chain rule, the product rule, and the quotient rule, then you can differentiate, well, pretty much any function. And I will try to demonstrate that here. Okay. So don't worry, it's going to be very pacey and you might lose track. So don't worry about it. If you don't lose track, well, congratulations. But I'll try not to mess it up. And I'll try to do it in under 10 minutes. Okay. So let's get going. So what do we see here? I see a product rule. This multiplied by this. So that's a product rule. So I'll start with that f of x dash. I'm going to find the derivative of that function. So dash multiplied by cosine x to the power 7 over 3 plus that function multiplied by the derivative of that. And the derivative of that is sine minus sine x to the power 7 thirds multiplied by 7 thirds x to the power 4 thirds. Okay. Now I don't need to do anything here because I've already found the derivative for this bit. So I can copy that here. Okay. Now I deal with this bit. With this bit. So this is a quotient. So because it's a derivative, it's a quotient, and it's something divided by that. And there's a product rule here, and there's a chain rule here. Okay, bear with me here. So it's 3 over 2 times x to the power 1/2, or square root of x, multiplied by sine x 1/3 plus cos x 1/2, close bracket, uh, plus x to the power 3/2, and x to the power 3/2 multiplied by cosine x 1/3 plus cos square root of x, multiplied by 1/3 x minus 2/3, plus minus sine square root of x multiplied by 1/2 square root of x. And then that's the derivative of this bit, plus minus sine x to the power 5/2 multiplied by 5/2 multiplied by x to the power 3/2. That's the derivative of the top function, and then I multiplied by x to the power 1/4 plus cos x to the power 2/3. So I don't touch that. And then I do minus, so it's the quotient rule after all. And then it's this function here. I don't need to touch that. So it's this multiplied by the derivative of the bottom function. And the derivative of the bottom function is 1/4 x to the power minus 3/4 plus minus sine x to the power 2/3 multiplied by 2/3 x to the power minus 1/3. And that concludes the top part of the quotient rule, all over x to the power 1/4 plus cos x to the power 2/3 squared, and then that multiplied by cosine x to the power 7/3 plus, well, plus that. Ta-da! Uh, that's it. I've done it. It doesn't look like it, but I have done it. Um, and it's horrible. I'm not even going to try to attempt to simplify it, but I have found the derivative just using the three rules that I have demonstrated, and I've done it in 6 minutes. So I'm quite proud of myself. This is almost exactly the same problem that I was given to me on my first test at university. I'll actually try to find it. Sorry, it's going to be a little bit of a Russian search. For the... Well, it actually was simpler than that. Yes. It's a slightly different here, but yeah, that's uh, Uh, oh, yeah. Well, anyways, I'll leave this. Yes, it was a very so webinars. No, alternate Tuesday, so every 2 weeks. Yes, we meet every 2 weeks. So every two weeks. And here's the if you go to our website, you will find the timetable, year 11 webinars, and it's here. So the next webinar is on the 25th, and it's Hooke's Law and Springs. Uh, yes, because the next webinar is on assignment 3, so we're not going to do any more differentiation. Well, no, we do differentiation, but not not as an assignment. Okay, brilliant. So I'll see you all in 2 weeks' time, and good luck with the assignment. Enjoy, and yeah, see you.